Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Kerana dengan limpah kurnianya dapat kita bersama-sama dalam menghadiri program Industry Talk pada hari yang mulia ini. Nama saya Aris bin Muhammad Taufik dari Fakulti Kejuruteraan Elektrik dan saya adalah juruacara anda pada hari ini. Bagi memberkati majlis kita pada hari ini, dijemput saudara Muhammad Faizuddin Omar untuk mengetuai bacaan doa.
Terima kasih Haris. Mul kita Al-Fatihah. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهما كما ربياني صغيرا. اللهم إنك عفو كريم تحب العفو فاعف عنا وعن جميع المسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات برحمتك يا أرحم الراحمين. اللهم افتح علينا حكمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين. رب اشرح لنا صدورنا ويسر لنا أمورنا واحلل عقدة من ألسنتنا يفقه قولنا. اللهم افتح علينا فتوح العارفين وارزقنا فهم النبيين وحفظ المرسلين وإلهام الملائكة المقربين في عافية يا أرحم الراحمين. اللهم إنا نجعلك في نهور أعدائنا ونعوذ بك من شرورهم. اللهم بدد شملهم وفرق جمعهم وشتت كلمتهم وزلزل أقدامهم وسلط عليهم كلبا من كلابك يا قهار يا جبار يا منتقيم يا الله. اللهم يا منزل الكتاب يا مجري السحاب يا هازم الأحزاب اهزمهم وانصرنا عليهم. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. صلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم والحمد لله رب العالمين.
Amin. Terima kasih diucapkan kepada saudara Muhammad Faizuddin Omar atas bacaan doanya sebentar tadi. Sebelum kita terus ke sesi perkongsian pada pagi ini bersama panel kita, sukalah saya untuk memperkenalkan sedikit latar belakang mengenai panel kita pada hari ini. Nama diberi Siti Fatimah Kamsani merupakan salah seorang jurutera PCB dan sekarang bekerja di Dyson Manufacturing Sdn Bhd sebagai Senior PCB Engineer. Beliau berpengalaman sebagai jurutera PCB selama 14 tahun dan sudah bekerja di 5 kilang. Beliau juga bekas pelajar dari UTM dan berjurusan dalam kejuruteraan elektrik kuasa. Selain itu, beliau juga mempunyai sijil kecekapan dari Selangor Human Resource Development Centre dalam bidang kejuruteraan elektrik. Jadi tanpa melengahkan masa, lagi saya menjemput Puan Siti Fatimah Kamsani untuk memperkenalkan dirinya dan perkongsiannya pada pagi ini. Majlis mempersilakan.
Terima kasih moderator. Okay. So, Assalamualaikum and a very good morning to all. I am Fatimah from Dyson Manufacturing, and today I will be sharing with you about PCB engineer role in the industry and the latest technology used in PCB manufacturing. Also, at the opportunity for James Dyson Award at the end of the sharing session. Just before I start, I would like to thank you to the event organizer, Dr. Arni and her team, also to UiTM Pasir Gudang generally for this opportunity for me to contribute back to our society as a speaker for this talk. I really hope at the end of the day, students will have some knowledge about PCB and PCB engineer role. So some background of me, the moderator actually already talked about it, but yeah, let me talk it about it again. So I've graduated from UTM at the year of 2007 with bachelor degree in electrical engineering. And after that, I landed an offer to enroll a one-year program under Selangor Human Resource Development Center to study in depth in PCB design. So this program called Industrial Skill Enhancement Program in SEP is a fully funded program by government that year. So I take the opportunity and I believe my career as PCB engineer was destined by that moment when I accept the offer. So other than competency certificate that I got from the INSET program, I also have acquired certification from the Institute of Printed Circuit IPC in CID and CID Advanced during my time in Dyson. IPC is a non-profit organization, member driven and leading source for industry standard training, industry intelligence and public policy advocacy. IPC is the global association that helps OEM, original equipment manufacturers, EMS, electronic manufacturer service providers, PCB manufacturers and suppliers build electronics better. So, if you are going to go into electronic manufacturing after you graduated, IPC is actually a language that we will use to communicate about product quality standard between customer and supplier.
Puan,
Yes?
are you sharing your slides?
Yes.
We cannot see your slides.
Great. Can see now?
Okay, now we can see it.
Okay, I'm very sorry for the technical difficulties just now. So, I will moving forward. Let the gone be bygone. The other two slides before. Alright. So what is printed circuit board? Or in some other region, they will call it printed wiring board. So I believe everyone have imagined a green board with lots of electric components on it. But even though it was not always green, but you are right, that piece of board holding electronic components together and give electrical connection is what we call printed circuit board. So we have several type of PCB in our practice, which starting from single-sided PCB. So yeah, I show here why it called single-sided. It's called single-sided because of the copper is only one layer. So here this PCB if you can see, the copper is underneath on the other side of the board. So the component will be mounting at this on top and will be soldered at another side. So the copper one layer, it called single-sided PCB. And then number 2 is double-sided PCB. So double-sided means double the copper, top and bottom. Top and bottom. So and the third one is multi-layer PCB. Multi-layer PCB, if we see it bare in our hand, we cannot really know it's actually how many layer is it. But for those who draw the PCB, for surely know how many layer is it lah. And then for the next one is a flexible PCB. This is 100% flexible, the PCB. And the second is a semi-flex PCB, or we also call it a rigid flex PCB, because we have this one, this two is a rigid and this one is the flexible. Usually this flexible is to replace a connector. And the last one is a HDI, high density interconnect. So the complexity is higher than the rest. So this is what the future will look like. Even though a lot of electronic devices actually already in HDI type of PCB. Okay. So now let me show you an example of an electronic device without PCB. Oh, sorry. I have another one. This PCB with component is called PCBA. So this one, when it's a bare without component, we call it bare board or PCB. But if the PCB have component, we call it PCBA, printed circuit board assembly. So I want to show you here is a electronic device from 1948 that did not have a PCB. So we can see here a little bit messy, and I believe it very hard to troubleshoot if your TV have problem during this area. And then this is a picture of the PCB engineer draw a PCB with tape and mylar before ECAD arrived. ECAD is electronic computerized aided design. So this is a outlook of a modern day PCBA with help of a ECAD. The copper we can see here is of finer lines. Component is smaller, and the PCB if the PCB is smaller, and even if it same size, the function will be they can cater a lot more function lah. So moving forward, who is PCB engineer actually? So in the layman term, PCB engineer is actually a middleman in between circuit designer and bareboard fabricator. They transform the schematic design by circuit designer into Gerber for PCB fabrication. So we have an what we call here image. Okay. So PCB engineer is in the middle in between circuit designer and a PCB fabricator. So here, circuit designer will give output in a schematic and give it to PCB engineer, and PCB engineer need to export to Gerber. And with the Gerber, we give to PCB fabricator to fabricate and become a PCB. That is I can say very straightforward arrangement, but in actual actual practice actually is a lot more complicated than that. We take information from the schematic, also the mechanical information in 3D and 2D drawing, and make it input, take it into our ECAD system. And from there, we do the process of making the PCB, include some concept from design for excellence, which is DFM, design for manufacturing, design for assembly, design for test, and design for reliability. And when the function of the board, function of the system become more complicated, we will add more concept to the PCB consideration while we doing the layout, which is compliance and safety requirement. Compliance, for example, if we want to send our product to China, they have this do and don't. All of that we need to comply before we can sell our product to China. The same goes to Europe or any other country. And then for the safety requirement, the more voltage you go, so um, we don't want our customer get electricity, right? So the safety requirement is something that we need to take care, especially when you play with battery. And then when a PCB engineer already finish their layout, we will give our output to the PCB fabricator and PCB assembly. So the output here is Gerber. What is Gerber actually? So Gerber is a file, a series of file that in a format of ASCII vector contain information of each physical board layer of your PCB. So what is physical layer? Physical layer is something that we can see in our hand. So we can see in our hand. So from the PCB, I did not have a example in my hand because I'm at home. So but the PCB, if we can see, usually they will be color, right? Green or red, yellow, blue, black, white. So this color is actually comes from solder mask. But okay, we talk about this one first. So the essential is the copper top and bottom that acting as a conductor. So and then another one is the second most important thing for me is solder mask top and bottom. Solder mask is to prevent solder from accidentally bridging, because currently our artwork, our layout has become narrower and smaller. It will be high chance for us to have a bridging solder if we did not properly solder mask our PCB. Other than prevent the PCB have proper bridging, it also protect the board from the environment, such as oxidization lah. Okay, the next one is a seed screen. So seed screen is not essential actually. It used to identify component, test point, parts of the PCB, warning symbol, logos, marks, and etc. But with the more high density PCB, the more seed screen will be not used, because seed screen will add the thickness of the PCB, and then your your stencil, when solder paste want to squeeze, they will be uplifted a little bit, and will disturb your solder paste quantity on top of the PCB. So and then the last one, but the most important one also is a PCB outline that shows the boundary and the size and shape of the PCB. Okay, so the next one I will show with you is how from the Gerber, our fabricator will make a PCB. This video is how double layer PCB are fabricated. I will not explain the process, but as PCB engineer, one should have known the basic process of PCB fabrication. With the knowledge, it will help us to understand the capability and prevent us from over-design our PCB.
From last 4 years, I am making hundreds of electronics projects. In almost every electronics project, I have used PCBs, but this time we are going to China, to a city called Shenzhen, to show how PCBs are actually made. And thanks to PCBWay for inviting us there. After we make a PCB order in their website, first engineers inspect our uploaded PCB file. They conduct a DFM review by checking the trace widths, the space between the traces, hole size, etc. and ensure the design is error-free and fits within manufacturing capabilities. After checking several circuits, they combine them on a large production panel, which is much more efficient to handle through the factory. Thus, the production cost also decreases. First, the board is dry cleaned in a machine and then cutted in small pieces, which is suitable for manufacturing. After cutting the boards, they come to the drilling room. Drilling is done for two purposes: for connecting the leaded components and for the via holes that link the copper layers together. First, the operator takes a MDF board as exit material. Then he loads one or more PCB panels and places it on the machine. And finally adds a sheet of aluminium as entry foil. Those machines are computer controlled. After selecting the right drill program, the machine starts working. Drill change is fully automatic. The machine selects the drill to use from the drill rack and checks that it is the correct size, and then loads it into the drill head. This is a air-driven drill which can rotate up to 150,000 revolutions per minute. The high-speed drill makes the whole walls cleaner. After that, the corners are trimmed to make it rounded. Then, the surface is cleaned. The machine automatically smooths the edges of the boards, one side at a time. As the board has drilled for making connection between top and bottom layer, but the middle layer is non-conductive fiberglass. So to make connection between top and bottom layer, the board comes for electroplating. The operator loads the panels onto the flight bars. The panels themselves act as cathodes for electroplating. The panels are carried through a series of chemical and rinsing baths by the overhead crane. This is a multi-stage process and everything is controlled by computer to ensure about 1 micron thick copper has deposited over the walls of the hole. After that, the board goes through a series of process where copper is plated up to a thickness depending on the required final finish for the panel. This process took about 40 minutes of time, and then board automatically goes to another room for next step. To enter into this room, we need to put on a special type of anti-static clothes, and we need to pass through a dust cleaning chamber. Then, panel is first coated with a layer of photosensitive film, the photoresist, which is hot rolled onto the copper. This machine do this automatically or sometimes done this process manually. This film is blue light sensitive, so all the lights into the room is yellow, so the light does not affect this film. Then the operator cleans the films. The film is the one which already has printed circuit diagrams on it, and loaded the first film. Then put the laminated panel, and finally the second film. After perfectly aligning both layers, the board is sent to the printer. The printer uses powerful UV lamps to harden photosensitive film according to the circuit printed film. So after this process, only the circuit part is hardened and rest unwanted areas remain soft. Modern machine can do this whole process automatically. Next, the board is processed through a chemical solution or developer that removes the unhardened and unwanted resist from areas that were not polymerized by light. After this, you can clearly see only the circuit is printed by blue resist, and this material will resist the chemical at the etching process. Then the board is sent for the etching. This process is to remove the unwanted copper using a powerful alkaline solution. After etching, the boards need to be cleaned and washed to remove the excess chemical solution. Then the boards come for automatic optical inspection or AOI. This machine enables fast and accurate inspection of PCBs to ensure that the quality of product leaving the production line is high and the items are built correctly and without manufacturing faults. When detecting circuits, the machine automatically scans the PCB through the camera, collects images, and compares the tested solder joints with the qualified parameters in the database. When everything is okay, then the board comes again to another yellow room for solder mask. This coating machine simultaneously covers both sides of the panel with epoxy solder masking. Solder mask is required to protect the copper surface and prevent solder shorting between components during assembly. After applying solder mask, panels are now racked and put through a conveyorized dryer at 87 degrees Celsius, which hardens the resist just enough for the next stage. Usually it takes almost 25 minutes to bake. Solder mask is applied to all over the board, so to remove the solder mask from solder pad, first, the operator takes the PCB and then align the photo film carefully at both sides simultaneously. The UV lamp in the machine hardens the ink where the film is clear. Later on, the unhardened and unwanted resists are stripped off. Most PCBs have a component legend to show which component goes where. They use inkjet printers to image the legends direct from the board digital data. This printer is very advanced. The operator only needs to find the silk screen file corresponding to the board and set the positioning on the main control computer. Then the ink will be applied on the boards evenly and automatically. Moreover, it can also be printing and curing on the same system. To protect the copper of solder pad from oxidation, hot air solder leveling is often chosen as surface finish method for circuit boards. In addition to the usual HASL, they also provide a variety of surface treatment methods such as immersion gold, hard gold and OSP for customers to choose according to their needs. Finally, the PCB production process is done. Then they electrically test every multi-layer PCB against the original board data. Using flying probe tester, they test the high voltage insulation and low resistance conduction of the circuit boards and check each net to ensure that the circuit is complete and there is no short or open circuit. For high volume production, they use automatic e-test machine which saves time and money because it runs at a high rate. After all testing, the boards come into the milling room. Now it's time to separate all individual PCBs from the large production panel. The operator loads one or more PCBs onto the CNC machine. And choose the right program for those boards. According to customer needs, the board or array can also be V-scored so that they can easily be broken apart after assembly. After milling, the board comes for cleaning. This machine cleans dust and oil stains using ultrasonic waves. After wet cleaning, the boards are dried. Then a team of sharp-eyed inspectors give each PCB a final and careful checkover. She looks for any cosmetic defects like scratches and marking, also checks aperture, thickness, holes, etc. After inspection, the PCBs are vacuum sealed and bubble wrapped to keep out dirt and moisture. Then the packets come to the packing room. After printing out the production release note, PCBs are securely boxed inside foam wrapper. And at the end of the day, courier comes and takes the package and delivers all over the world. Hope you have enjoyed this video. This was a lot of fun and also I have learned a lot from them. Hope you have also learned something new. So that's it for now. See you in my next video. Until then, bye bye.
Yep, that's about it. To fabricate a double layer PCB specifically lah. For multi-layer, the process a little bit different. So now, like I already okay. So before I already said about the HDI technology that has become our something I can say a future technology. The latest technology that we have in PCB design. So this HDI, they are very fine print. The via is very small. We cannot drill by a driller. So how are we doing HDI PCB? We will use laser. So this is an example that I can find, a video that I can find for this PCB. What happened? Alright. They did not have any sounds, so maybe you can just watch and enjoy. Tada! It's done. More faster, but I'm not sure about the yield. Maybe they have a lot of machine that can cater a lot of yield. So next, alright. Okay, so next is I want to share about my experience in a different company. So the first company I start drawing PCB is with test tooling solution. I joined this company for 6 months as on-job training while I in the inset program. So this company provide automated test equipment solution fixture for Intel to test their BGA. So some of the board that I have done are to test their lifetime, the BGA lifetime, their contact resistance, IC continuity, also thermal verification. So that is what I already learned when in my 6 months over there. So if you can see here, okay. So if you can see here, this is what the PCB looks like. The automated test equipment solution. So this is the automated test equipment. So what this company provide is this PCB. This is actually quite big. If you see, the size is the same as the monitor over here. Then we will put the IC that need to test. We will put at the center, and all the socket that link to this machine will be put at the side here. It's good. Looks like quite simple, but actually the layout technique is different based on what customer want to test. So for this job here, there is no schematic provided by customer when I do. So customer only provided the part drawing, which is the BGA drawing. What kind of test they want to do and list of the pin that they need to be tested. So in this company, I will not only draw PCB, I also need to create the schematic for to have the layout. Also, I need to do the footprint for the component, which is the BGA here. The socket, usually we use the one that we already have in our library. And then after we finish design, we will show to customer first actually for validation if they are okay with it, and then only we proceed. So this company actually even though they are small, but they actually fabricate their own PCB. When I do my practical in test tooling solution, the CAD ECAD that I use is called Cadence. This is the same software that I learned during my class in SHRDC. So not so hard to catch the software. So after test tooling, solution, Sanyo is my first job. So this Sanyo, if you try to search now, you will not find it anymore because this company already bought by Panasonic. I think the same year as GST implemented in our country. So already buy. So this company is actually designed car audio for Suzuki and Dell battery pack. I did not get enough experience to design the board actually, but I really value what I learned the most is on how component placement affect the production yield and machine capabilities. If you see here, so this is a single layer PCB. The copper is only at one side. And we can see here how the component has been placed because all of this will be dipped into solder wave. So you see actually the direction of the wave is like this. And the IC, we did not put it in 90 degree, we put it in 45 degree angle like this. So we will not have a shadow effect. And if you see also at the edge of the connector, they will have a solder trap. So this is something that we need to think when we place the component prior to the layout, prior to the connecting the dot. So at Sanyo, actually I use different software, which is Zuken. Zuken is originated by Japanese company, I think. So yeah, a new learning curve, not a problem. So the next after Sanyo, this is where I spend most of my years as PCB engineer. Is it at PNE Electric? So PNE have their own product, which is exit sign and emergency lighting. The name would not be very famous, but actually if you go to UITM later, if you check, if you have exit sign, you will see actually PNE supply a lot of exit sign and emergency lighting in a lot of places lah. So other than I do product designed by PNE, owned by PNE, I also actually support uh, layout design for Philips. I do have support a lot of various product, but the one that I remember the most is actually the Philips Hugo. This because I do it from scratch. It means from the bare PCB. Customer give me some what we call kepercayaan to do the layout after so many years. Yeah. So because this company, even though they have their own project, at the same time they provide PCBA service. But then since I already there doing some layout and the product is not so much, the variation is not so much, so they offer also PCB design service to their customer. So during these 6 years, I work in PNE. I use another software which is Altium. Another software. Yeah. Okay. And then during 2016, I moved to Dyson. So this is where the this company is totally different lah for me because the challenge of become PCB engineer in Dyson is we did not have our own PCBA line, which is the production will be due at our contract manufacturer. So in here we use Mentor Graphic. At first when I come to this company, it's actually not to become a PCB. It's a PCB engineer but not drawing a PCB. It's just for taking care of their library. So the library, what is mean by library? Because every component is actually special. They have their own figure, they have their own value. So Dyson have this one system to control what every electrical engineer choose to use. So we can buy it in bulk. Everyone can only select what we already have in library, which is I maintain globally. So we can buy, it's cheaper lah when we can buy more quantity. So and then after 1 year half, 1 year half I think, dalam 1 year half they open for PCB engineer position in Southeast Asia. So I apply and then I success. Now I become PCB engineer. So that is the journey. So that is the journey of the my career as a PCB engineer. Anyone, do you have any question, Arni? I think that's all. Oh, maybe
Alright.
I forgot. Maybe I forgot to make a slide here about the criteria to become an PCB engineer. So when I job hunting from the beginning of my career, every post will ask about degree in electrical. You need to have a basic in electronics, but when the times goes and I go to I meet a lot of PCB engineers, other PCB engineers, they not really have degree actually. So some of them only have diploma, but they have working experience in electronics field. So from there they change career like what I do also from librarian to PCB engineer. Alright.
Alright, thank you, Puan Siti Fatimah, for sharing your understanding towards PCBs and your history as a PCB engineer. So, shall we go on to the questions from our viewers?
Yes. I
Alright.
still have 2 slides, but that
Alright.
one we save for later.
Okay. So, the first question is, there are so many colors of PCB boards. You know, like just now you showed there's green, purple, blue. You know, that's very abnormal. For a normal consumer, such as ourselves. So, does the color affect the performance of the circuit, or is there like a purpose to have different colors?
Okay. So usually in Dyson we use 2 colors, which is red and green, to differentiate the stages of the product maturity. So the product that we convinced that it can go for mass production, we will make it in green. But for one in still in development, we will use in red. But actually, it will not affect the performance, but actually it will affect the PCBA assembly because the red color it becomes more thicker and it's thicker. So when they want to barcode laser mark barcode for the each PCB, uh, the machine in our contract manufacturer cannot protrude and make a code over there. So that is one of the challenge lah. we can use, but it will give effect to another party, such as the one I said to you at PCBA level.
I see. Okay.
About other color,
Mhm.
okay, we have. For usually white, I use I already at PNE I said I designed for Philips Hue. That one is a LED. So that one, the PCB, the solder mask color is white actually. So they give more reflection of the color. Uh, so and then the blue color, I never designed that, but I think that's their preferences. Yellow never. Black, yes. Black is some of the Dyson product, their product is transparent, right? So we don't want our customer to see the PCB, but the PCB is stood there. So we want to camouflage, we put it in black color. So that also can become a reason lah.
I see.
Right.
I actually have a black PCB with me right now. So I understand that. So we can go on to the next question. This is from Fatimah Zahara from UITM. She would like to ask that does the different colors of PCB indicate different qualities?
I didn't think so. Qualities in what matters? Performance quality or the robustness of the PCB quality? I don't think it give effect. But if the color, like I said, the red color, it affect your process, that maybe it will affect the outcome of the process lah.
Understandable. Okay, so the next question is how do we know what we should uh how do we define the quality from the manufacturer of the PCB board?
That one need to ask quality assurance engineer. Alright. How to define eh? Okay, so every time every month actually our contract manufacturer will give some report, yield report. So when that yield report is showing that how many PCB that they throw away because of not function, cannot deliver the value that we want. So from there, is actually something not right happen lah. Because we always do um before we send our gerber to our manufacturer or to our PCBA assembler, we already define what stages of difficulty about this board. So if they cannot do, they should let us know they cannot do, so we can give to another CM lah, contract manufacturer. So when they agree, when they want to take the job, they should fulfill the quality that we want.
Understandable. All right. So moving on to the next question. The HDI will produce faster than the traditional PCB. But how about the cost to design the design and the fabricator, I assume?
Okay, so the one that I show in the video is actually one piece of PCB. But
Mhm.
if the traditional PCB, even though it takes a longer time, but actually at one time process, they in one panel they can have around. It depends on the size of the PCB. The mother panel is 1 meter squared actually. So they will process one time, and the yield is actually more bigger than using laser, I believe.
I
But
see.
yeah, because Dyson did not use that technology yet, we did not have any keperluan for to use that technology. So I cannot give the exact uh, comparison between process.
I
But
see.
for sure, the laser, latest technology, they will charge us the machine they buy to us. So it become more expensive.
I
But if
see.
you want to fight your competitor to, yeah, that is small PCB, you need to fit in a lot of circuit because you want to more function, more, um, more, more fancy. So you have to buy, you have to pay lah.
I see. So would you prefer the HDI or the PCB, or the traditional PCB?
I did not have any preferences because it's not my money. But I think it's best we do what is optimum. If we no need to go to that, no need to use that technology that is more higher price and will give more higher price to the product itself. So we don't go to use that technology lah.
Understandable. All right. So the next question is from Amira Aiman. Um, does Dyson Manufacturing provide PCB manufacturing to the public, or is it only for Dyson products?
Uh, Again,
Uh, does Dyson Manufacturing provide PCB manufacturing to the public, or is it only limited to Dyson products?
okay. Well, even though the name is Dyson Manufacturing, we did not manufacture in our house. We give to other CM contract manufacturer. We have 5. One of them is Flextronics. So SKP, Ata. So this company is actually they can produce, they can manufacture, they can assemble another company. But they sign an NDA with us. So anything that confidential must stay confidential.
Understand. So moving on to the next question from Muhammad Safi Rohmat. Do you personally take part-time PCB design jobs?
Honestly, yes. But that one is before Dyson. Uh, when I come to Dyson, the pay is good. So I think the responsible also higher lah. So you cannot afford to have any distraction because when you start take a job, sometimes you will drag until night. So if you have two responsibility, if you take a job, you need to send. So if you cannot take the responsibility, you cannot send, better you don't take the responsibility lah. So but I do have when I in PNE, I take a part-time job.
Understand? Okay, this is from Harvard Lim. Miss, how you are going to test the functionality of design Gerber file as PCBE, or you will have back and back feed, feedback procedure with PCBA tester after the testing is done by them.
What do we want to test? Mm, can you repeat again so I can
Uh,
understand more the question?
I think Harvey Lim is trying to ask like how, as a PCB engineer, how do you
Mm.
test the Gerber file, like the functionality of the Gerber file?
Okay, when we do PCB layout, before we generate Gerber, we already run design rule check. So design rule check is to make sure that any constraint that we put inside is meet the requirement lah. The requirement that is set by electronics engineer and the requirement that we place in automatically based on the DFM and DFA and DFT. I mean, so if you have no if you have no error, all the error has been cleaned up, then it's actually safe to generate Gerber and directly go to supplier. It will not, because this is a intelligent software. Uh, we no need to check by our eyes lah.
Understand? Alright, so the next question is for Fakirul Azif. You have so many different experiences at various companies. Which one is the best company for you and why?
Of course, Dyson. I have I have a lot of opportunity. Okay. Why I said the best. Hmm. Here I can grow. In here, in Dyson, I can grow. When I come to Dyson, I only a PCB engineer, and now I already become a senior. In some company, if your senior did not leave the company, you cannot be senior, even though you 20 years at the company. So and then it has perks lah, that fancy perks. Also, I think the most important thing is my boss is a very good boss lah, very understanding. If I until late, it's because I want to work until late. It's not because of him. Uh, it, my work-life balance, and yeah, okay. So
I
far so good.
see. I see. So do you personally use Dyson products?
Yes, I have two.
Oh,
One is a complimentary because um you pass your, what we call it, Hmm, uh trial months. When
oh,
you come to new company, you have trial, right?
the
3 months. So
probation month.
yes,
Yeah,
probation.
I
So
see.
so they give you one, not so free lah. You need to contribute back to James Dyson Foundation $75, not dollar, RM. So $75 you get that machine, that price around 3,000 at that time.
I see.
So
Wow.
every employee actually will have at least one product. But I just bought another one is in health. What do you call it here? Mm,
Vacuum cleaner?
yes, the one, the cordless vacuum cleaner
Wow.
for my usage. Okay.
I see. All right. So the next question is also from Harvard Lim. Any website or resources for those who are interested to venture into PCB?
Website venture into PCB. I did not. I did not. Um, I never find that any website. But the information is here and there actually. But even though I take my certificate in PCB, in IPC, IPC is a standard, right? For that proven method, proven practice, and the stable practice. But when you come to the company, they have their own standard actually. So the one that you learn in IPC, that one, um, it's not invalid, but you have to follow company policy. They already have their best in class practice, so we use that.
I see. So would you say that your interest in PCB designing or PCB engineering came from your main interest, and so if you already have that interest, how did you like venture into that interest? You know what I mean?
It's like playing Lego tau.
Oh, okay.
PCB design. You have to be very fast. I don't know. It's just some satisfaction if you can make a good PCB.
I understand that feeling.
Uh,
Yeah,
the pressure, the time. So when you finish, and then they said, yes, this PCB you do already go to SOP. something that personal satisfaction.
I see. All right. So the next question is, how do you prove your competency to apply for the job? Since that a lot of companies don't use ECAT.
A lot of company don't use ECAT.
Yeah, because just now in your slides you showed that some use Etium, some use
Mm-hmm.
different softwares, right?
Mm.
But but
So how I
you
convince them?
yeah,
Because I don't use that ECAT before. So actually ECAT they for PCB they are all the same. You just need to find the GUI.
I see.
The first 3-month probation is where you show your how far you can study, how far you can um,
Adapt,
invest
invest.
to the company lah.
Understandable. So in that probation month, is that also the time where you try to understand the software that you use?
Yes.
I see.
Alongside with the company standard. The first 2 weeks you must read company standard.
Understandable.
Mm.
And another question is, in your opinion, what is the best character for one to be a PCB engineer aside from holding an electrical engineering degree?
Character and degree. What? I think that's general for everyone. PCB engineer because okay. So now we have more, especially Dyson is targeting double Dyson. It means double product Dyson. So we are going to have a double also the workload based on so and then so the character is I think you with the PCB become more smaller and so they will introduce a lot of pressure in term of space. So I think don't easily give up lah.
I
Don't
see.
easily give up. But if you tired, my boss said, put the glass down for a while.
I see. So it seems like PCB engineers need to be very tenacious lah.
Yes, that
Yeah,
is one
I
word.
see.
Mm.
I think adaptability also, since nowadays people really like small form factors, right? Like
Adapt Adaptability is a must when you work in a private company, I believe.
yeah, I
Mm.
see. Because a lot
After
of
all,
people
we need to fight. Everyone want to duplicate Dyson, right? Even though the iklan also they want to copy how
Yalah.
how we advertise the product, so it becomes more challenge. We need to make the product to a market early, as fast as possible. So we will be the first. It's hard actually compared to the first backless Dyson Cyclone, right? So
I
Cyclone
think
is
so.
actually a technology that James Dyson itself managed to put a not benchmark apa tu pattern.
I
So
see.
just this lately, everyone is come with cyclone vacuum, right? It's
Uh-huh.
already been used by Dyson 20 years ago. After 20 years, only the patent
Expired.
can expire.
I see. Oh, that's unfortunate for James Dyson.
So now they try to find another I know fancy technology. So maybe after that they patent and he's like that lah.
Understand. Well, Dyson products are quite different from other products, from
Mm.
what I can see. This next question is, why are Dyson products so expensive? The vacuum costs 2,000 ringgit. Does Dyson gives you discounts?
Of course, Dyson give us discount. At
I
one
see.
time, 2 years ago, I think 50%. But
Oh,
even though it's 50%, it still cost 1,000. So I don't buy
yeah,
it that time lah. But
understand.
okay, why you pay it so expensive? Because you actually pay for the technology and the R&D and the testing.
Understand.
So our here this supersonic, their prototype is, if I'm not mistaken, hundreds time prototype only before it came to uh, they call it at first what is the term, concept design. Then when they confident, then only it came to SEA for development lah. So to have this one, they do it so many times, so that is what you pay lah actually.
I see. Well, Dyson is known for their bladeless design kan. So
Hmm.
macam tu lah. I can understand the pricing, and also the marketing is also different. Maybe that's also another reason, right? Mm. So the next question is, what is the biggest challenge in the next 5 to 10 years for PCB fabrication?
The biggest challenge I having now is when the IC, the chip is become smaller and smaller, but our fabricator cannot meet, cannot run along with the smallest and finest copper, finest artwork. So I think that is because of the pay also. If they can go, to into more fine, but they want to charge more lah, right?
Mhm.
But
Understand?
okay, about money, I don't really know lah. Just but the challenge is like that because every time you give geber to them, then they said, this one not manufacturable. This one will give you ni. This one will give you. They come back to us. What we can do. Uh, so if you want to use this type of VR, this one it will cost you double the price, whatever.
I see. The next one is a personal question from me.
Mm.
So, what if in a later time, the trend will be clear products where the internals of a certain electronic can be seen? Do you think that will be a bit more pressure towards you as a PCB engineer to make the PCB more kemas or more aesthetically pleasing?
Oh, actually, we always do that, even though you did not see it.
Oh.
Okay, but the first, when I do PCB, the first is functionality. The first is functionality. So, but the first is functionality, and then after that, it goes to component placement lah,
I see.
block by block. So because the first is function, second then only become nice.
I see.
Nice is the satisfaction of nice. No need to have another person to notice us lah for PCB engineer. Every one of us,
Understand?
because if we actually we can auto route, if we put enough constraint, we can actually auto route, but we prefer to do it by ourselves lah,
Understand?
so it more nicer, the more straight.
That question came from me because yeah, I like seeing nice PCBs, like the copper linings and everything. So that's actually caused the curiosity.
The
Yeah,
one you see that have parallel along the way, that is I think product that have um It's a lot of digital signal, such
I
as
see.
maybe motherboard, maybe hard disk. Because in normal consumer product like Dyson here, you seldom see that kind of continuous trace because after all the
Understand.
PCB is so small, how it can be so long.
Understand. Uh, so uh, so to the viewers out there, do you have any more questions or if
Uh,
there isn't, do you have anything you want to say, Puan Siti Fatimah?
I have another 2 slides here to promote
Mhm.
student out there, especially student, to join James Dyson invention, not invention, award lah. It's a competition. It's a competition. So let me share my screen here.
Oh, I am a student. Let's see.
Yeah. Do something. Where is my? Okay. So this James Dyson Award. So you see the national winner. National winner, it means Malaysia stage. You can have a 10,000 RM. But for international winner, you can have a 160,000 RM for your product to be success. Not success. Become reality lah. Become reality. And it will give 27,000 more for your university. So lecturers, do support your student when they want to do some innovative design. Maybe today the entry close is 30 June, which is 3 days. Which is in 3 days. So maybe if you want to think about the idea now, maybe I'm not sure. If you maybe already have, you can uh, you can join the competition lah. So because we still have because the price is very okay. Let me share this one video from our James Dyson.
Design awards are usually about making products that look beautiful, but that's only a tiny part of the story. For me, the importance of the award is to solve a problem, question things, challenge things. I've always truly believed that young people want to change the world, and that's absolutely right, they should do. And it gives them the confidence that they can literally do that. Winners get the notice they need to move forward with their idea. And I think it gives investors confidence as well.
So if you are interested, please do visit the James Dyson page because it's open to current university student of engineering, product design and industrial design, and recent. Recent means here is in the last 4 years. So if you already graduated but less than 4 years, you can still join the competition. This James Dyson Awards is actually run by James Dyson Foundation. It's a charitable trust as part of its mission to get young people excited about design engineering. Somewhere that I read that it opened to only 28 countries. But if you are originated, but not in UiTM, UiTM all is Bumiputra, right? So if outsiders, let's say which country? Maybe Myanmar. I'm not sure if Myanmar can join us. But if he or she study at Malaysia, he or she still can apply, still can being in the competition, because the rule is university must be in the 28 countries. The university, not the originated of the person itself lah. So yeah, please just send your innovative thinking. So maybe with that 30,000 pound, you can realize your product.
I see. So maybe for us UiTM students, you know, we can use our FYP
Yes,
FYP projects.
for sure, because
Yeah.
I already 2 times become a juror in UiTM on your FYP project. In the last, I'm not remember what year, but it's already 2 times. I've been dragged by your madam Arni.
Yeah. um all right. So there's one more question. So is the James Dyson Award like a research grant to develop a prototype until it becomes the real product?
I think so. Develop that specific product that you send that you entered.
I see.
Mm. We can find. Let me share my screen. We are sharing. Share. So let me share. Can you see, Aris, my website I open here? James Dyson's award website.
I think we're still at the slides from just now.
See. The software is tired of me. Cisco Webex service is not responding. Hello?
Yes.
Okay. So at least my sound, my voice is still there. So I cannot share with you guys. But please do Google search James Dyson Award and see some entries from previous. They show you what the past winner, what is their status for now. And also this year entries also has been posted inside, and you can see how they sell their ideas. They just have some sketches. Doesn't mean that you need to have a real product to show actually. So we have two categories, one international, and the one is sustainability. So until now, my Webex is still in not responding. I think that's all I can share for today.
Yeah, all right. That's understandable. So I think there's no more questions regarding PCB engineering. So with all that said, I would like to say thank you Puan Siti Fatimah Kamsani for sharing your understanding and knowledge regarding PCB engineering. And to the viewers out there, uh, I would like to remind you guys to fill in the attendance form in the chat so that you can get your e-certificate. All in all, my name is Aris bin Muhammad Taufik, and I would like to apologize if I have said anything wrong or I have been inconsistent. So I would like to say thank you to everyone for attending today's session for Industry Talk with Puan Siti Fatimah Kamsani. That is all from me. Assalamualaikum warahmatullahi wabarakatuh.